So, until we have on this continuation of the two-port network, earlier we have studies the Z parameters, Y parameter, ABCD parameter, and now the fourth one is terminated two-port networks, which currently we have studies to resume to previous lecture of two-port networks. So terminated two-port network is uh, basically a symbol of the symbol of two-port terminated two-port network is given below, in which we have some impedance is connected the input side, and the load impedance is connected to the output side. So this type of parameter give the relationship between this input characteristic and the output characteristic of the given system. So let's start with this two-port network. What we have to study the characteristic of this two-port terminated two-port network, right? See, ZG in this figure, the ZG represent the internal impedance of the source, and VG the internal voltage of the source, and ZL is the total impedance which is connected in the output side of the port. There are few characteristics of the terminated two-port network, and some of them are like this. The input impedance is generated by ZI, and it is the ratio of input voltage to the input current. Similarly, the output impedance Z0 is equal to V2 divided by I2. It gives the ratio of the gives the ratio of the output voltage to the input voltage. And if you find the gain of the system, then you have to written like it is gives the input relationship output current to the input current, and overall gain, the voltage gain. The voltage gain is represented by V2 by V1. Overall voltage gain, that is denoted by AG, and it is the ratio of voltage to the voltage gain. The, the derivation of any of this desired, the derivation just yes, yes. The derivation of any of two desired expression involve the algebraic manipulation of two-port equation. Have you remember that if we uh, write in the terms of Z parameter or Y parameter or ABCD parameter, we have to write its principal equation. For example, if we take the Z parameter, then we have write the proper uh, Z parameter equation, which is given that V1 is equal to Z11 plus Z12 I2. This is the equation number 1. Similarly, V2 is equal to Z21 I1 plus Z22 I2. In this this is the terminated two-port network figure. Applying the KVL on this input side, and let's see what happens. Once we have applied the KVL at the input side, the input voltage is written in form of V1. V1 is equal to VG minus IZG, and it is denoted by and written in the form equation number 3. Similarly, the KVL of the output side, which is applied on this side, right? This side applied on this side, and it is represented at V2 is equal to minus I2 by ZL, which is equation number 4. From this equation, all the characteristic can be obtained. Mind you, what I have said, from this equation, these are the three basic equation. By applying this three basic equation, all the characteristic can be obtained of this ABCD characteristic means all these parameter can be found by using this formula, right? Now let's take some example of some question problem of this two-port network. Yeah, this is the same problem. For the two-port shown below, obtain the suitable value of RS such that the maximum power is transferred at the input terminal. The Z parameter of two-port network is given as in the matrix form, which is shown here. You have to find the at which value maximum power can transfer from the input side to the output side. Just take the solution. Z parameter equation becomes V1 is equal to 6I1 plus 2I2, and this is referred as equation 1, and V2 is equal to 4I1 plus 4I2 is equal to 2, which can be written in for the given matrix. Step number 2, you have to apply the KVL at the output port, in which we get V2 is equal to minus 4I2, and substituting this equation in equation number 2. Substituting this equation number 2 into equation number 2, we have find I1 by 2 minus I2. Again, here is the one is the unknown. So two unknown is things. So write the equation number 4. Substituting the equation number 4 into equation number 1, then we have find the V1 is equal to 5I1. Again, we know that the I1 value is known to anybody. So Z1 is equal to V1 by I1 is equal to 5. For the circuit have a maximum power, RS is equal to Z1 is equal to 5. So this is the value at which the maximum power can transfer from input side to the output side, means source to load. Let's find out the other characteristic of this equation by using this is overall gain. By putting this formula V2 by Vs, we have find out gain. Similarly, V1 is equal to from this equation we can find the equation. When we have drawn this pen and paper step by step, go through it and find out all the parameter and the characteristic of these equations. Let's take the second example. Earlier we have taken Z parameter. Now we've taken the ABCD parameter. ABCD parameter of two-port network is given like that. The output port is connected to the variable load for the maximum power transfer. Find the RL and the maximum power of the given circuit. So solution, we redrawn the circuit. Just wait. Yeah. See, this is the given equation in which we have find the solution. So the ABCD parameter equation became V1 is equal to 4 V2 minus 20 I2. This is the equation number 1. I1 is equal to 0.1 V2 minus 2 I2. This is the equation number 2. At the input port, V1 is equal to, see the figure. At the input port, when we have applies KVL, we have write V1 is equal to minus 10 I1, and 3 into 1 from equation 3 put it as equation number 2, then we have to find 10 I1 is equal to 4 V2 minus 20 I2, in which we have find I1 is equal to this much minus 0.4 V2 2 I1. This is the equation number 4. Equate this equation number 2 and 4, we have got the equation number 5. From 5 we have find that ZTH is equal to 8. And now let's from the output side, once we have configured the output side, the V1 is equal to minus 50 minus 10 I1 and I2 is equal to 0 as shown in the figure. Substitute this equation then we have find the equation number 7 and equation number 8. Substitute equation number 8 into the equation number 7, then Vt is equal to 10. Thus the Vth is equal to 10 volt. So the RL from the maximum power transfer, RL is equal to ZTH. Earlier I have said that the maximum power transfer from source to load, which earlier we have studies in maximum power transfer. How can the maximum power can transfer from the input side to the output side? So RL is equal to ZTH is equal to, we have find the 8 ohm, the maximum power P is equal to, by getting the formula I square by RL, and this maximum power transfer theorem says that the P square TH divided by 4RL, then putting the value of P, TH and RL, then we have find 3.12 watt. This is the basic equation of the how can the maximum power transfer from one side to the another side. Now next topic is the hybrid parameter, or we can say that it is also called the H parameter of the network. It is very much used in the field of electronics by modeling the transistor especially. So main application in the electronics field, and it is also called the H parameter, as they use Z parameter, Y parameter, voltage ratio and the current ratio to the respective in respect the relation between the voltage and current in the two-port network. H parameter is useful to describing the input characteristic of the circuit, where it had to measure Z or Y parameter such as transistor. Earlier I have said H parameter also encapsulate all these important linear characteristic of the circuit, so they can very useful for the simulation work. The relation between the voltage and current in H parameter can be represented as the principal equation we have written. This one, V1 is equal to H11 I1 plus H12 V2, and I2 is equal to H21 I1 plus H22 V2. This can be represented as the matrix form, V1 I1 2 by 2 in the form of 2 by 2 matrix form, and which is given below in the circuit. See, once we have modeling this H parameter, then we have to short circuited the output terminal, which is represented here in the slide 2 dash, which is short circuited. Means the voltage between these two terminals is equal to 0. Once the voltage is equal to two terminals, V2 is equal to 0, the value of V2 is equal to 0, we have put it in the equation in the principal equation. Once we have put it in the principal equation, we find the value of H11, and the H11 is nothing but the ratio of the input voltage to the ratio to the input current, and this is referred as the input impedance. This is referred as the input impedance. Similarly, we have find the H21, and this is represented as a short circuit current gain. This is represented as a short circuit current gain. Yeah. Just a second. Yeah. This is called the short circuit current gain of the network. Now let's us open the circuit of the port ones. Means you have open the input side circuit. So it means I1 is equal to 0, but remember this thing: some voltage, the voltage difference this port appears in the network, right? And once we have put the I1 in the master in the principal equation, we have get H21. H12, which is called the open circuit reverse voltage gain. And similarly, we have find out the H21. It is referred as a admittance of the circuit. So these are the basic thumb rule of finding the value of H11, H1, H12, H21, and H22. Yeah. The next topic of this, how we actually model the H parameter, means how you equivalent network of two port network, how the H parameter equivalent to the two port network. To draw this H parameter equivalent network, first we have to write the equation of the voltage current as usual using H parameter, and which is given below. Now equation 1 can be represented as the circuit based of the Kirchhoff voltage law, which is written like this. And equation number 2, which is the output side, and the circuit is represented like this. Once we have combined these two parts of the network, then we get the equivalent circuit of the H, H networks. So this kind of the steps we have applied to solve the H parameters. Now before ending this lecture, let's summarize all the parameters which we have studied in the two port network. First of all, we have studied the impedance, Z parameters, Y parameters, T parameters, and the terminated two port network and the H parameter. Let's identify or how this tool are used to solve the complex problem in the network. So earlier I have said this impedance parameters is used to analyze the impedance matching to the network and the power distribution network, right? And the Y parameter are also called the admittance parameter, and and the unit of the Y parameter is Siemens, and it is give the ratio of the current and the voltage. Therefore, this admittance matters give the relationship between the input and output. And T parameter, also called the transmission parameter, is widely used in the field of the transmission and distribution sector. And the H parameter is used in the modeling of the transistor basically. So these are the summaries of two-port network. In your curriculum, you have to studies of such these things. Before I am ending this lecture, I would like to request you, all of you, to solve some numerical problem of given given Y parameter, Z parameter, and do H parameters. To more, you have more convenient to solve the equation in exam. Thank you.